Indeed, Rijksmuseum, the Maritime collection of Rijksmuseum includes over 300 half models, and they are transferred from the Department of the Navy to the Rijksmuseum from 1883 on. A half model is a scale model from the starboard or port side half hull of a ship mounted on a wooden backboard. It is constructed in wood, painted and finished with a transparent varnish. Sometimes a label is attached to the backboard with information on the scale, name and provenance of the model. We distinguish different kinds of models. On the upper left corner you see a bracket model indicating the frames and ribbons of the ship. This type of model makes up more than half of the collection. We see it executed with gun ports, the white squares, or without. Right from the bracket model, we see a more elaborated version planked above the waterline. The gun ports are cut out and the backboard is painted. The labels mention the various ships that have been built after this design, and this illustrates the archival function a half model can have. On the lower left corner, you see a model that's totally planked and the frames are not visible. And on the right lower corner, you see the most elaborated version of a half model. And there are only few such models in the collection, and they seem to have had a merely representative function. Well, like Lieselore said, despite the great number of models in existence, little is known about their production in the Netherlands. Knowledge about half models is previously been gathered from archival and historical documentation, and such information is scarce. As a result, most of the half models in the Rijksmuseum collection cannot be attributed to a specific dockyard, are not associated with actual ships, and have therefore been assigned wide production date ranges. Moreover, the function of half models is ambiguous. It is assumed that they played a role in the 18th and 19th century Dutch shipbuilding industry, but what role exactly is not defined. The production of half models flourished in the late 18th century, half a century after ship design drawings were introduced in the Netherlands. And until the 18th century, Dutch ships were built without drawings. Shipwrights worked according to a set of rules, proportional rules, and their private experience, making each ship different. And this method had proved to be successful enough until the new naval tactics like the line of battle called for a more predictable and standardized performance of warships. So with the introduction of drawings in the 18th century, the design phase was separated from the construction phase process. And ship design started by drawing the main frame of a ship, a frame in the back and a frame in the front. And the dimensions of the other frames were derived by a complex geometrical construction, which I will spare you now. But once this design was complete, the coordinates of the frames were collected in a table of offset, like you see on the left illustration. And the information was transferred to a lofting floor. The frames were drawn there in real size. And from these drawings, the actual frames were constructed, like you see this happening in the upper right picture. So what would be the role of a half model in this process? Was the model used to make the drawing, or was it made according to the drawing? And if so, why? This leads to the following research questions. First of all, when and where were the half hull models constructed? And to answer this question, Marta Dominguez del Mas has performed chronological research on the objects. The second question is, what was the function of half models in the Dutch shipbuilding process in the 18th and 19th century? And to find an answer to this question, we study stylistic features, tool traces and marks, and construction. And also I made a half model myself. I reconstructed a half model. As for dendrochronology, backboards are an integral part of the models, and they're often made from a single oak plank. And the annual growth rings visible on the sides of the backboard can be analyzed with non-intrusive dendrochronology. And the information retrieved is an estimation of the felling dates of trees and identification of specific geographical regions. To learn More about the function of the half models, visual research is performed on each model. And I looked at stylistic features, such as different ways the gun ports or the stem can be represented. I looked at marks, tool traces, and construction. And here we focus on signs that can tell about the sequence of production and signs that suggest if the half model is made according to the drawing or the other way around. In order to gain insight in the methods of construction, I made a mock-up, and this process, which, as you can see, is not finished yet, but points out where in the actual half model collection we have to look for tool traces and marks. So I can share some results with you, all preliminary as it is an ongoing research. But as for dendrochronology, Marta has researched the backboards of 68 half-hull models, and the results are fantastic because she found 10 clusters of backboards that originate from 10 individual trees. So we can assume that these models made on backboards from the same tree have been produced at the same dockyard. And if one of these models is attributed to a specific dockyard, like for example here the Chatham that we know is constructed in Rotterdam, we may assume that the others have also been produced there and around the same time. The estimated felling dates of the trees combined with the known and suspect production date ranges of some half models within each cluster help us narrowing down the wide production date ranges. As for research on the function of the model, I will take you through some examples of tool traces and marks. For example, we find in many models a hole in the mid-frame, and these holes are around 2 to 3 centimeters deep, and if you would put a stick in it, it would enable the model to be placed upright on a horizontal surface. And the presence of consoles in the lower and left and right corner of the backboards, often an integral part of these backboards, support this idea of an option for a standing position. And on the bottom of the consoles, we often find cut nails. And this all leads to the question, why would one like the model to be standing up instead of lying or hanging? Well, you could think this all comes in handy if you want to place the backboard perpendicular to the drawing and to transfer the lines of the drawing to the backboard or the lines of the model to the drawing. And the nails will pinpoint the position. On the frames, we see scratch lines and pencil marks that indicate the position of the gunnel and shear line. And as you can see, these positions are taken from the backboards and are transferred with the hook to the outside of the frames. And this means the position was copied to the backboard from the drawing. So the models were made according to the drawing. And this is confirmed by the fact that we see the position of the frames scratched in the backboard. Also, we see punctures above the frames, and these are often filled, but one could think of a batten positioned here to draw the shear line, or to check the smoothness of the curve, or to keep the frames in position when they're not fixed yet, and I will get back to that later. Also, we notice punctures on the top side of the frames, and these indicates quite likely the use of a batten that is temporarily fixed to the top of the frames to position them in the right angle to the backboard and at the right distance of each other. We see punctures in the backboard adjacent to the frames, and we see them at random heights. And these punctures correspond with corroded dents in the frames. And my assumption is that during production, the model maker used iron nails to temporarily position the frames. And the corrosion must have been caused by the iron of the nails reacting with the tannins in the oak, catalyzed by humidity. We find most frames are numbered, and the numbers are difficult to see and even more difficult to picture, but they're important as, according to literature, each shipwright had its own way of numbering the frames. For example, in Amsterdam, they generally started counting from the mid-frame to the front in capitals from the mid-frame to the back in Arabic numbers, while in Rotterdam and Zeeland they started at the front and counting back to the back in Arabic numbers. Also, the amount of frames used per model differed, and literature suggests that each shipwright used a specific number of frames for their ship design. Another distinction is the way the frames are attached to the backboard. In general, we find the frames nailed from the backside of the backboard, and in some cases they are inserted in rabbets that are cut from the front side of the backboard. On the right picture, you see what this looks like. An interesting phenomenon are the holes in the backboards of many models, and we see them in different shapes and sizes, and some are even cut through a label, like you see indicated at the white arrow. We assume these holes are made to or used to store the models, maybe on, for example, on metal or wooden bars, and the distances between the holes are measured and noted because they may be indicative of the same storages. So maybe we can cluster them according to these distances. Very important are the adjustments sometimes made to the construction of the models. And shipbuilding has always dealt with the elusive concept of fairness, which means the harmonious flow of a hull from bow to stern. And what we see here is that a piece, one of the frames is adjusted and a piece of wood has been added to the backboard side of the frame to make the frame wider and to make the contours on the outside run smooth again. I will show you what that exactly means now, because as for production, my production sequence, my hypothesis is that the main frame was first placed on the backboard. And it would have been too invasive to deconstruct this half model to show you, but so you have to imagine the other frames and ribbons are not here yet and focus on the only frame in the yellow square. And with the help of a metal rod that is inserted in the hole of this frame, the backboard with this frame could be placed upright in a vertical position on top of the horizontal drawing. And again, I have to make an appeal in your imagination because the drawing used here is not corresponding to the model, but if you would imagine it would be a bit wider, you get an idea of what it would have looked like or worked like, because the drawing was then transferred to the back panel with the two-bladed set square and a pair of dividers. Then a wooden slat was nailed at the position of the shear line, and the other frames were positioned according to the lines that had been transferred from the drawing, and the frames were halted by this wooden slat. And they were temporarily fixed to the backboard with nails on both sides. You see them indicated with the yellow dots. The square angle with the backboard was secured with a batten on top of the frames, and now for the fairness of the shape was checked, and eventual adaptations were made. For example, you see at the yellow arrow that the line is bulging, and one could adjust this by making the frame a bit smaller, and that you won't notice. But if you would have to make the frame wider, you would notice, like I just showed you in this picture. So when all the lines had proven to be fair, the frames were nailed permanently from the backside, and the battens and the nails were removed, and then the ribbons and gunnels were fixed. So the making of a reconstruction was very instructive about sequence of production, and it shows that also that some shapes cannot be derived from a two-dimensional drawing. For example, the measures of the gunnel, which you see indicated in red line here, they can never be derived from a two-dimensional drawing. They have to be taken in the 3D model, and this is much easier to do on a scale model than on a full-size ship under construction. So the use of a model helps to estimate the dimensions of the wood needed for the planking. So, concluding, when and where were the half models constructed? Well, if we group the models according to the dendro results, and we find one of the models of this group is known to be produced at a specific shipyard, we can attribute models from that group to that same shipyard. Moreover, based on significant similarities in construction or stylistic feature, we may also attribute undated ship models to this group. And according to the dendrofelling dates, we can narrow down the actual production date ranges of the models. As for the function of half models, tool traces in the marks indicate that the models are taken from the drawings and not the other way around. The models may have been used to check these drawings if they were correct and or if adaptations were needed, and maybe they were also used to explain the design to people not familiar with reading drawings. And finally, they may have been used to estimate the dimensions of the wood needed for the planking. So far for the conclusions, but there's more future research to be performed. We can look at comparison and study of the paint layer stratigraphy of the backboards. XRF, we can perform XRF on paint layers and metal parts. We can identify the wood used for the models, the species. We can perform X-radiography on closed-hull models. We can research the drawings in the archives connected to the models to see if they were the same size as the models and if we see any marks or if there were any adaptations or adjustments. And archival research may also connect some models to historic ships. So the results of this interdisciplinary research should lead to a database that will give a more complete picture of the half-model collection of Rijksmuseum, but maybe also enriching for other half-model collections. So I would like to thank these people and thank you as well for listening.